everyone. My name is Kelly Lynn Brinkack, and I'm from Virginia Beach. I am the Sounding Rockets Program Manager, as well as an environmental scientist from the Environmental Office. Our mission is called ENHANCE, which stands for Examining the Nature of High-Altitude Noctilucent Clouds and Their Environment. Next slide, please. ENHANCE will study and compare a variety of noctilucent cloud measurements with data from previous NLC missions, such as the AIM satellite. Over the course of our mission, we hope to analyze changes in the clouds over time and determine if they would truly be viable as an indicator of climate change. Next slide, please.
Hey, I'm Vic West from Sounding Rocket Platform, and I'm from Manassas, and our position is research scientist from the Science Office. For our mission, we choose to research further on data collected from Noctilucent clouds. Noctilucent clouds are massive clouds that form when the water vapor freezes down the specks of dust. They form in the upper atmosphere for roughly 80 kilometers above the Earth's surface. They're most commonly found in the northern hemisphere every year from May through August between 50 degrees and 70 degrees latitude. They're not always visible by the human eye, and they're primarily visible when the sun is just below the horizon. Next slide, please. They're made by burning fossil fuels, which delivers gases like carbon dioxide, methane, and water vapor into the atmosphere, all of which are greenhouse gases. And by the condensation, nuclei through cold temperatures, and the presence of water vapor, they form. Also, over the past few decades, we have seen an increase in the Noctilucent clouds, and this mission can help us identify specific data on the Noctilucent cloud. Next slide, please. So our NASA goal we have is to discover and expand knowledge for the benefits of humanity. And we do this by examining the effects of climate change and Noctilucent clouds over time, and specifically is to understand the Earth's atmosphere by expanding the data collected about the Noctilucent cloud. Next slide, please.
My name is Benjamin Boone, and I'm from Virginia Beach. I am a research scientist from the Science Office. Our first science goal is to confirm and add to data from past missions, specifically the aeronomy of ice in the mesosphere mission, or the AIM satellite mission, which is pictured here. To accomplish this goal, we will first record the temperature and altitude of the Noctilucent clouds, and we will use these in conjunction with each other to develop a temperature profile of the cloud. We will also be collecting physical samples of the ice and dust particles from the clouds, which upon recovery will be examined to determine their composition. Next slide, please. Our second science goal is to examine the effects of climate change on the Noctilucent clouds over time. To do this, we will be studying the chemical content as well as the concentration of ice crystals in the clouds, because greenhouse gases have been shown to cool the mesosphere, which increases the water vapor and therefore the ice crystal concentration, leading to larger and more frequent clouds. Next slide, please.
Hi, I'm Eddie Jung, a student from Richmond, Virginia, and I am an applied scientist from the Science Office. NASA and the Wallops Flight Facility will support and fund our mission. Wallops Flight Facility in particular will help provide the rocket construction and launch sites. The EPA will also help with grant money and environmental advice, while orologists and the scientific community at large will benefit from our research and data that we hope to collect. Now, on to the next slide, please. This mission's impact on the local economy near Wallops Islands, pictured here, will be seen in increased employment, while a boom in tourism should be seen whenever a launch occurs in Norway and Alaska. On the global scale, the price of international cooperation is hard to gauge, but the stability of our interdependent world market relies on peaceful allies maintaining the status quo, which our project only strengthens. Furthermore, the adverse cost of ignoring climate change should be realized, as improved research in this field will help lower the chance of a global depression from global warming. This mission's impact on society is in increasing awareness of our favorite global stress factor, as more believers in this fact means more voters willing to step up for change. Finally, the expansion of our knowledge in climate studies and aerology has a real positive impact in scientific research, as in order to better understand how to combat the problems that our world faces, we must first better understand our world ourselves. Now on to our next slide and slide this, please.
Hi, my name is Eddie Gibson from Henrico, and I am an applied scientist from the Science Office. There are quite a few legal matters that must be settled before we can be permitted to launch. We require an experimental permit from the Federal Aviation Administration, which is required for all new rocket launches. Obtaining this license requires performing hazard analysis and determining maximum probable loss over a several-month-long application process. Since one of our rockets is launching in Andøya Space Center in Norway, we were required to go through a couple of entities in order to transport our sounding rockets to the center. First, we need to obtain a transport license from the center itself in order to have permission to bring the sounding rockets there. The second and more difficult barrier is going through the International Traffic in Arms Regulations, or ITAR. We must go through them due to our export of rockets into Norway, and the process can be very long and difficult to get approval from them. Another entity that will aid us is the International Law Practice Group, which will give us legal advice and give us some advice in dealing with international space laws. Next slide, please. Enhance also must follow wall of flight facility safety procedures in order to be allowed to launch, including providing the facility our nominal flight trajectory and the characteristics of our sounding rocket as well as their limitations. We also must design a ground safety plan, designed to minimize the risk of personnel and property involved in preparing the rocket launch. A flight safety plan is also required to minimize the risk of our rocket causing damage while in flight, including avoiding collisions with other vehicles in the sky. Last, but certainly not least, it is important to ensure our sounding rockets in case something does indeed go wrong. Next slide, please.
Hello, my name is Leah Weitz from Stafford, and I'm one of the instrument specialists from the engineering office. The instruments that we're utilizing in Enhance are the infrared thermometer, the aerogel dust collector, also known as ADC, the global positioning system, also known as GPS, and radar. Next slide, please. The miniaturized laser heterodyne radiometer, also known as mini LHR, and lastly, the cloud aerosol and precipitation spectrometer, also known as CAPS. Next slide, please. Each of the instruments used in this mission have been chosen because they're the best fit for what we are trying to measure. The infrared thermometer is able to provide us with visual images of the temperatures of the NLCs, which will help us determine the conditions. The aerosol dust collector is able to collect a sample while maintaining low interior temperatures without leaking the sample or breaking it. The cloud aerosol and precipitation spectrometer supplies us with graphs that shows the concentration of the ice crystals and is measured in micrograms per cubic meter of air. The GPS and radar will display the elevation of the clouds by triangulating signals from different satellites and will be measured in kilometers. Finally, the mini heterodyne radiometer will concentrate on the different levels of gases found in the NLCs. Thank you. Next slide, please.
My name is Austin Baker from Hanover, and my position is instrument specialist in engineering. The sounding rockets we are using has a payload range of 200 pounds to 800 pounds. All of the weights are provided on the slide. The telemetry system holds the batteries, radar, GPS, and radio system. The instruments will have to be waterproof so it does not get damaged from the salt. The waterproof seal will add 15 to 20 pounds. Overall, everything is 250 pounds. Next slide, please. We'll use 5 24-cell batteries. The transmitter, instruments, mission system, timers, and switches will all have one battery each, and they'll have one extra. Each battery will last about 5.5 minutes, which will give us a runtime of 20 seconds, which is 7 minutes longer. Next slide, please.
Hello, my name is Nikhil Suresh from Centerville, and I'm an environmental scientist from the Environmental Office. The platform we will be using is a 2-stage carrier-inflated rocket. This rocket has 2 motors allowing it to reach an altitude of 80 to 200 kilometers depending on the payload weight and trajectory. The rocket weighs 2,900 pounds without the payload. Next slide, please. Before launch, the rocket will be in a styrofoam box for insulation and protection against the weather. During launch, the box is displayed and a ground crew cleans up the remains to ensure there is no harmful local wildlife. After splashdown, the rocket will sink to the bottom of the ocean to limit the impact on marine life. The payload will be recovered and reused. Next slide, please. The trajectory will be planned ahead of launch so it won't impact the habitats of endangered species. Next slide, please. Through the enhanced mission, we will develop a better understanding of NLC and validate information from previous missions like the AIM mission. The enhanced mission will help us learn more about the composition of these clouds and how they are affected by climate change. Next slide, please.
Our mission will last for 5 years, starting in 2022, with a total of 30 sounding rockets. We will launch from Norway and Alaska, both of which are located in the polar regions of the Northern Hemisphere. Each summer season, we will launch 3 rockets from each site. We will use ground-based LiDAR to determine our exact launch time and trajectory for each individual location. The clouds last for at least a day, so there's enough time after cloud detection to set up and launch the rockets. We will then compare our data averages over the 5 years for the 2 different locations. Next slide, please. The process from the start of our design phase to testing to launch will take 2 years. The design phase will only happen once because we are using the same design for all of our rockets. The remaining platforms will be constructed following the launch in 2022. Next slide, please. Each individual launch will last for 20 minutes, with the rocket reaching its maximum altitude at 10 minutes and the payload detaching at 17 minutes by parachute. In Norway, the payload will be recovered off the water by boat. In Alaska, the payload will be recovered off the land by helicopter. Next slide, please.
Hi, my name is Ari Bobesh from BERC. I am a public relations specialist of the Office of Communications. The enhanced mission logo contains a lot of symbolism, but it was also important to be simple. For this reason, the mission name and launch year are clear in the foreground of the patch. Also in the foreground are 3 sounding rockets which symbolize the triple conjoint launches each NLC season. In the background, you can see a picture of the Earth with Noctilucent clouds, the phenomenon which we are studying. And around the outside, the stakeholders surround the mission as if they are caring parents hugging us. Next slide, please. Our educational outreach program focuses on advertising our mission and curricula to international, national, and local conventions and organizations. We do this so that we reach a broad audience of science teachers and demonstrate parts of the mission in person. Next slide, please. Our curriculum focuses on the role clouds play in the water cycle. We reinforce a certain scientific phenomenon like condensation, evaporation, and climate change through experiments such as the cloud in the bottle experiment and others for all ages. We also recommend the GLOBE program for any students that desire to learn how to identify clouds that they see in the sky. An example of one of our flyers is on the right. Next slide, please. Here, there is an example press release on the left and an example fact sheet on the right. Next slide, please.
Hi, my name is Ronnie Interlicia. I am a PR specialist from the Office of Communication. We have created a website to house all the information about this mission, as well as more ways to get involved. Next slide, please. We have also created an art contest where the winner gets to attend a launch from Poker Flat Range. Next slide, please. We have created various social media outlets for people to receive updates about this mission. Next slide, please. We would like to thank our master teacher, Casey Bruder, intern Reed George, education liaison, Victoria Dana, subject matter experts, Eric Roper and Valerie Giselle, the staff at Wallace Flight Facility and Virginia Space Coast Scholars for setting up this academy for us, and our amazing parents for supporting us along the way. Thank you.
Okay, nice job. All right, once again, if you have a question, please type the word question in the chat box and we will call on you as they're in line. Okay, Becca.
Hi, this is a question for the Office of Communications. How will you aim to solidify public support for this mission, given that climate change is a polarized topic in today's society?
Using the fact that climate change is such a polarizing topic, any mission that seeks to find out more information about it is generally elevated in the public's view, and this can be used by our team to sell the mission to the public as something that they want to see completed successfully. Does that answer your question?
Yes, thank you.
Okay, Liz Petrie.
I believe it was the applied scientist made a comment about the difficulty of getting permission to go into Norway. What happens if you don't get permission? Do you have a backup plan?
So there are some other, well, first of all, if Norway doesn't approve us, we can still launch from Alaska. So we would still have a good amount of data to pull on. We could potentially just move most of our rockets to Alaska and do it from there. Norway is just in case that there might be some more info to gain by shooting off in a different area. So I think that even if that's disapproved, there are some other countries who could probably take a look at if it came to that. Though I hope that they would be willing to let us shoot rockets there. But if there is a problem, again, Alaska, I think, would provide fine enough data for our purposes.
Okay, thank you.
Okay, Joyce Winterton.
Yes, good presentation and exciting mission. How will you transport your sounding rockets to Norway, and how long will it take?
Thank you for your question. So it will take about a month or two to transport our rockets to Norway by boat. So yeah, 1 to 2 months, which we did factor into our timeline for that 2 years that will take to build each rocket, or each set of rockets.
All right, thank you.
Okay, Rachel.
Hi, I was wondering, how will you measure or detect when the clouds will occur?
We have at each of the locations in Norway and Alaska, we have ground instruments, specifically LiDAR in Norway and radar in Alaska, that will be powerful enough to detect the clouds.
Thank you.
Okay, Max King.
Hi there. Great job on your presentation. My question is, your plan is to launch 30 rockets from 2 remote launch locations. Are these launches reusing the previously flown hardware? If so, how many flights do you plan per payload, and how will the hardware be refurbished?
Thank you for your question. We have decided to use a surplus military motors or rockets to power our sounding rockets. So that automatically cuts off a lot of expenses that would come if we were building a brand new rocket. So that's how we're able to afford so many rockets. And then each rocket, we will not be recovering after the flights, but we will be recovering our payloads and reusing those, which will detach by parachute, and we can easily recover those either off water or off land. But as I said before, the low cost of these surplus military motors will allow us to afford so many launches, even though we're not recovering each rocket.
To add on to that, we have not yet considered how many launches each payload will be used for.
Okay, Shelley Huger.
Hey, nice job, you guys. I think this is a really interesting topic. Office of Communications, you guys gave a couple of ideas for us teachers, Cloud in the Bottle and the Globe program, which are both awesome. But I'm just wondering, what are your thoughts on teaching like upper level students, AP Environmental Science, this topic? Any ideas?
Hi, thank you for your question.